Limits notes. All right. I know some of you have gone through pre-calculus. I don't know if any of you have been in calculus, but if you have, cool for you. I teach limits a little bit different. I teach it as more of a visual representation, especially because we got Desmos, right? So, did you guys find the page? Business calculus limits notes. It's on page something. We have no pages. Okay, so I want you to think of a limit as something that we get really close to. So if I had like this, and I keep going this way, this is going to infinity. Agree? So that's not really a limit. But what if we have like something like this? Like a weird looking volcano graph. Well, we can approach from this way and we can approach from this way. And the fortunate thing is, it appears they're both going in the same direction. They're both going up to a certain direction. Let's say we had a graph that did this. And this. And let's say we're trying to get to here or here. Well, this is a limit that could exist as long as we are dealing with a direction. It doesn't exist if we're dealing from both directions. Because usually a limit is, where am I getting to? Okay? Unless they specify we're coming from a certain direction. Okay, so let's head down. Let's just graph the first graph on Desmos and see what it does for us. All right, so we have x squared minus 2x minus 3 all over x minus 3. So we're going to go y equals x squared minus 3. Let's make this division. And we're going to go x squared minus 2x minus 3. And then underneath, we're going to go with x minus 3. Okay. And they want to talk about a certain direction we're going here. Okay. So they're saying, what is the limit as x approaches 3? So let me zoom in further so I can get all my numbers in here. Okay. So my limit, here's my 3 down here. So I want to know, what am I getting to as I get to right there? Now, this might be a tricky question. Okay? It appears that it's getting to 4. But this graph, you have a parabola over a linear equation. So I bet you if you were to factor out the top, you would find that something's going to happen at 3. And if you look on Desmos, if you go right here to 3, what does it say at 3? Undefined. Okay? What's that called in math? It's called a hole. Okay, so question I want you to ponder. If I'm traveling up this line and I get to 3, or if I was traveling down the line this way and I get to 3, are both of those getting to the same hole? Meaning as I come from the negative numbers up, so as I come from over this way, so horizontally, so I'm just going to travel up the graph, I get to a hole. As I come from the more positive numbers, so coming horizontally this way, or down, am I getting to the same hole? What do you think?
Yeah.
I think so. Yeah. Okay, so let's just think about that for a second. So tentatively, I would think that we're trying to get to the point 3, 4. Bless you. But the 3, 4 is an undefined term because it's a hole in our function. Meaning if I plugged 3 in for my x value, I'm going to divide by 0. Dividing by 0 is a big no-no in math. Okay, so let's just ponder that for a second. Let's look at the next example where I have 2 graphs. So we're going to graph x squared. Oops, meant to go y equals. And then y equals 1. Now, here's kind of the nice thing on Desmos. So that's what our graph looks like. Fantastic. I love it. All right. So we're going to say here, and I'm curious if Desmos is going to allow me to do this. Never mind. Oops. Okay, so the limit at 2, so it says x is not equal to 2. So I have a value here. Let's do this, x equals 2. Okay, so that purple line on our graph means something there, means something there. Okay, but for the parabola, the blue line, they say x is not equal to 2. Okay, for the green horizontal line, they say that x is equal to 2. Okay, what I want to look at is I have the point on my green line of 2, 1. I have the point on my blue line of 2, 4. So if I was traveling along the blue line versus traveling along the green line, as I approach 2, am I going between the blue and the green, and I get to 2, whether I go from the left or to the right or to both, am I getting to the same y value? Does that purple line cross both the green and the blue at the exact same point? When I say point, that means the x and the y value are the same. Whereas 2, 4 are a different point than 2, 1. Okay. So I just wanted to think about that for a sec. How are those things being transposed? We go down a little bit. We have a graph that kind of looks like this. Got a solid dot. Got an open dot up here. Comes down. You got an open dot here. Comes down. Comes up. I have an open dot here, but then I have a solid dot down here. And this keeps going. And let's see if I can establish some points. So this point right here is basically, looks like 6, 3. This point here is 5, 4. This point here appears to be 7, 4. This lower point here is 7, 2. And this point here is 3, 3. This point up here looks like it's 3, 6. I think we have enough stuff to answer our question. All right. And they're calling this whole equation is basically g at x somehow. So it's they call it a piecewise function because you have 2 functions that are graphed being represented. So if you were to look at actually this equation, it'd be like g at x is equal to this equation, and this equation, and this might be it's less than a certain number. That's not hashtag. And this, it could be greater than or equal to some number. Okay, so that's what we're looking at. So if we take a look, and we're going to say, I want to know the limit as x approaches 5 from the negative direction of g at x. Okay, so this means this little negative here coming from the left. Okay, so if I get to 5, which is here, if I've traveled down this line right here, and I get to 5 right here, what is this value here? Well, it should be 4. Oh, yay, look what happened. Best day ever. I was trying to get that fixed, and they're like, well, explain to us what it means. I'm like, I don't know what it means. So if I've got that negative 5, I'm coming to 5 from the negative direction, means I'm coming from the left. I'm coming down, so I have, this gets to 4. If the next one, right below it, says I'm coming from the positive direction, so if I change this minus to a plus, means I'm coming from this way, and as I get to there, I also get to 4. So my limit is 4. So as I come from both directions like this, am I getting to the same hole? Does that make sense? Is that the same hole? Are my fingers going to touch each other if they jumped over the hole? Make sense? No, that's anyways. I feel like Ferris Bueller's teacher right now. Like, oh, come on, dude. All right, so what that basically means is if I came from the left and came from the right and that same hole exists, that means my limit at that, limit as x approaches 5 from the left, limit as 5 approaches from the right, or if it just says the limit as x approaches 5, the third one down on that means that they're both coming from the same or from the opposite direction. So does the limit get to the same hole? And the answer is yes. So what is the limit? So what is the limit for the one I have listed as 5 approaches from the negative? The answer is 4. What is the limit as 5 approaches from the positive? It's also 4. What is the limit as x approaches 5, which means from either the left or the right? That is also 4. Okay? So that's going to mean a whole lot when this starts transpiring. And then they go, excuse me, I don't know what's going on. I don't know if I was yelling at somebody. Then they look at the 7. This is, at the 7 is kind of unique. So it says coming from the left, I get to 4. Coming from the right, I get to 4. And then it says, what's the limit at 7? What is that? So if I came from this way, I get here. If I come from this way, I get here. If I come from both spots, I get to this dot down here. So the limit as I approach, or limit as 7 approaches from the left is 4. As the limit as I approach from 7 from the positive direction is going to be 4. If it just says the limit of 7, it's that exact point right there. So 7 comma 2. So 2 is the answer there. So the limit does not exist as we would want it to, because the limit from both directions wants to get to the same point. But so if I go directionally, it means one thing. If it's not directionally, it means something else. And then limit as I approach 3 from the left, I get to 3. The limit as I approach 3 from this way, I get to 6. So if I have the direction coming, I can tell what the limit is. If it says, what's the limit as I approach 3, as my fingers go, notice this finger's up here, this finger's here. We're in 2 different locations. Okay, so the limit as I approach 3, not from a direction, but from both directions, does not exist because it goes to 2 different points. Okay, this one does not exist Whereas the strange thing that make light of, if we go back to the other one, is I come from the left here, I come from the right here, I get to 4. As I say, what's the limit as I approach 7? I have an actual dot that we're going to go with. But because these go from 2 different directions to completely different graph, okay, we're off the graph. Like my left and right just led to 2 different locations entirely. That means the limit right here does not exist because you have too much of a leap to take place. Okay, so let's take a look at example 1 down at the bottom. We can go back to Desmos so we don't have to deal with our computer. All right, so I'm going to go y equals, I'm not going to type in limit. I'm just going to do x to the 3rd, right? On that, minus 2x. Okay, now they're saying as x goes to 2. Vape alarm's going off. I'm feeling better about myself. Okay. So the limit as x goes to 2. There's no direction there. Okay. What point am I getting to? 2, 4. So my limit there is 4 because if I come from the left, I get to the 4. If I come from the right, I get to the 4. If I come from both, I get to that 4. Okay, so algebraically, that means something. If I took example 2, where we're dividing 2 things, it's very possible on that one, we're going to get... Do you guys feel safer that we have a vape alarm going off? I can tell you I'm sleeping better at night knowing that. So next example, we have x squared minus 4x. And then down below we have x minus 2. Oops, I forgot an x up top. All right, as x goes to 4. So I just like visually looking at it, x equals 4, vertical line. Okay. As I come from the left, as I come from the right, something's taking place. I'm getting to exactly 0, which is fantastic. Okay? So let me pause there because I wanted to give you guys, you got it, see you soon. I wanted to give you the opportunity to try. There we go. I knew I messed up on something, but we'll make it work. All right, will you try the page that says, I have to type it in because my thing's going to be goofy. It says Business Calc. It's got, looks like hand-drawn graphs in there. And do me a favor. Try just 1 through 4. Because there's something I have to talk to you guys about on number 4. So put a star next to number 4, because that's what's going to take place there. Cool? So business calculus, you can find that it's got the squirrely, it looks like that page. Just do 1 through 4. And that's all we'll have for today. Do you think they caught the kid vaping?